All right, this is our next lesson. We'll go over this on Wednesday, which is tomorrow. You're going to see it today. I think I'm going to choose this lesson as the second assignment that will go towards your test grade. So I do need to explain, and I'll probably go over the vocabulary tomorrow, but I do want to explain the perpendicular bisector. I know you have these drawings right here, but I do want to explain how a perpendicular bisector is drawn. Okay, so to have a perpendicular bisector, first you have to have a segment. Okay, because it's a bisector, it's cutting in half. Okay, so that means I'm gonna try to be right there. That's roughly half. Okay, so it's gonna cut half. Boom. That's my perpendicular bisector. That means it's gonna make this side and this side equal. Okay, so the way the perpendicular bisector theorem works is, well, if you have a said point, say up here, and you connect it to the ends of that segment, then this side is going to be equal to this side. Pretty much creating isosceles triangles. Okay? You have to kind of remember that. So that's what the perpendicular bisector theorem says. If you have a bisector that cuts a segment in half, giving you equal parts, then anywhere on this bisector, okay, anywhere, you can attach a point like that one, and you connect it to the end of that segment that you just cut in half, and you're going to create equal sides. That's what is drawn right there for you. So then you have the formal explanation. You have CD is bisecting or is intersecting perpendicularly with AB right here, creating two equal halves. That means that AD is equal to EB, so it says right there. And we finish with AC is congruent to CB. And remember, the converse is always the backwards of it. So on this one, it states that if you have two equal walls, AC is equal to CB, and then you have CB. Let me erase right here. Is a perpendicular bisector, because that's what we're talking about. So he is perpendicular to AB. We're going to say that these two are equal. So AD is congruent to DB. So now you know this is going to be your setup for most of the problems that deal with this perpendicular bisector. You're going to do two of your problems, and again, these problems rely on the fact that, oh, the two walls are going to be equal if this is a perpendicular bisector, or the two pieces of the base are going to be equal if that is a perpendicular bisector. So let's look at number one. Here we have number one. Here we have our 90-degree symbol, which is telling you that is obviously perpendicular because you have those two congruent marks. Then that tells you this is a bisector. So this side and this side, because of the theorem, are equal to each other. solve for x. Well, I'm going to just transfer that problem over here. 7x plus 24 equals 13x minus 48. All right, so let's move the 7 across, and we're going to get 6x. Or if we move the 7 by subtracting it, then we're going to move the 48 across. So we're going to move it across by adding it to both sides. Both sides, and we get 72. And I'll get 6x on the other. This is just multiplication tables. Divide